Okay, so this is a scalar product again about perpendicular vectors. So two perpendicular vectors, right? If they're not zero, they are perpendicular if and only if A dot product with B is equal to zero. No, we stress on the fact that it has to be non-zero. Right? Because if it's a zero, then it's meaningless, right? So if you have, for example, A1, A2, A3, right? A scalar product with a zero vector, then of course this will give us zero, right? So it doesn't mean anything, right? So two non-zero vectors, A and B, they are perpendicular if and only if the dot product of A and B equals to zero. Alright, if the dot product of A and B equals to zero, then either A equals to zero or B equals to zero, or A is perpendicular to B. So you can see that here, when the dot product of A and B is zero, there are many implications or several meanings. Right? So how do we use this to help us to solve examples? So one thing that will help us is that, why is this true? Because we know that earlier on, right, from the earlier tidbit video, right, A dot product with B, right, what is this equals to? This is as the more derivative of A, derivative of B, and cosine theta, right? Where theta is the angle, this is the angle. We call that this is the angle between A and B, right? So if A and B, right, are perpendicular, what will be the angle between them, right? Okay, so you're right, the angle between them has to be 90 degrees. So the angle between them is 90 degrees. This means that over here, okay, this will be equals to 90 degrees. Alright, so what is cosine 90? Cosine 90 will just be equals to 0, if you're right. So that's why it makes sense. So if cosine 90 is equal to 0, this whole expression here will be equal to 0. That's why you can see that if the two vectors are perpendicular, the angle between them is 90, and the answer will turn out to be 0. Alright, so let's look at how we can do an example. So if the position vectors of AB are 1, -1, so this is A, this is 1, -2, sorry, B is 2, 4, 1. Show that OA is perpendicular to OB. So what do you do? You show that their scalar product gives us 0, right? So quickly, we have 2 times 1, 2, -1, 4, -4, 2 and 1 plus 2. Right, so we have 2 minus 4 plus 2, so it's like 4 minus 4, and that will give us 0. Okay, and you can see, now OA, scalar product of OA and OB is equals to 0, right? And they are both non-zero, so it means that OA is perpendicular to OB. Alright, it's a very simple application. You can see the answers at the back.